Hello classmates. The content we are learning today is a turbine protection system, mainly introduce overview and main protection knowledge of the system turbine protection system to everyone. Overview of turbine protection system. In large steam turbines, severe exceeding of certain parameters can cause equipment damage or even damage accidents. For this reason, large steam turbines are equipped with stricter protective measures. Due to the greatest harm caused by unit overspeed in addition to overspeed protection and multiple emergency shutdown protections, severe exceedance of other important parameters is implemented through the emergency shutdown system. The turbine protection system includes the following three parts. Turbine overspeed protection. When the unit speed exceeds the protection action value, a shutdown signal is issued. ETS, Emergency Trip System. Emergency Trip System is a protection system collects all parameter values that require shutdown and sends a shutdown signal when any value exceeds the protection action value. Turbine trip system accepts all shutdown signals manually or manually trigger the shutdown solenoid valve to trip the unit. Turbine overspeed protection. Overspeed protection includes OPC, overspeed protection, and electrical overspeed protection, and mechanical overspeed protection. OPC overspeed protection, overspeed protect controller. The original purpose was to prevent overspeed of the system steam turbine generator set when the unit speed reaches 3090 rounds per minute. It prevents the unit speed from 110% exceeding 110%, 3,300 rounds per minute of the rated speed, and causing the steam turbine to trip. Electric overspeed protection. When the unit speed reaches 110% of the rated speed, 3,300 rounds per minute, an electrical shutdown signal is issued to interrupt the unit. The overspeed protection system has a fast response speed, high reliability, and safety. Periodic testing is required for electrical overspeed protection. Mechanical overspeed, it consists of a critical trip device, a critical trip device, a high-pressure trip component, and a critical trip device connecting rod. The operating speed is 110% to 111% of the rated speed, 3,300 to 3,330 rounds per minute. When the speed reaches the set value of the emergency trip device, the flying ring of the emergency trip device or flying hammer hits out, striking the spot hook of the emergency trip device, causing the spot hook to trip. The emergency trip valve in the high-pressure trip component is activated through the connecting rod of the emergency trip device, cutting off the inlet oil of the high-pressure safety oil and releasing the high-pressure safety oil, quickly closing each inlet valve and shut down the unit. Main ETS protection for steam turbine. Main ETS protection for steam turbine. Low vacuum in condense. Low lubricating oil pressure. EHO pressure is low. Axial displacement of steam turbine, high and medium pressure cylinder differential expansion. The mental temperature of the bearing is high. The vibration of turbine bearings is large. The inlet steam temperature of the main steam valve is too low. The oil level in the main fuel tank of the hose is low. Generator maintain protection action, electric trip. Boil MFT, furnace trip. Protect the main hazards of refusal to move. For example, if the vacuum of the condenser drops and the protection refuses to move, the consequences are: first, reduce thermal economy and output of the steam turbine unit. Second, raise the exhaust temperature, causing thermal expansion of deformation of the low-pressure cylinder, and lifting of the bearings behind the low-pressure cylinder, damaging the center of the unit and increasing vibration. Third, increase the internal stress of the copper tube of the condenser and damages the tightness of the condenser. Fourth, reducing the enthalpy drop of steam inside of the turbine, increasing reaction degree of the stage and increasing the axial thrust may cause damage to thrust pad. Third, main phenomena. The vacuum of the condenser decreases. The exhaust temperature of a low-pressure cylinder rises. Sound and light alarm for low condenser vacuum. Standby vacuum pump starts in combination. The temperature of condensed water is abnormally rising. Unit load decreases. Main reasons: circulating water's pump failure tripped, standby pump did not start automatically, or circulating water volume was insufficient. The pressure of the shaft seal decreased or is interrupted. Damage or leakage of vacuum system, pipelines, and equipment. Handling methods. If a vacuum job is detected, check for alarms or any operations that may affect the vacuum job. If any, stop immediately and restore the system's operating mode. Check that the backup vacuum pump should start automatically, otherwise manually start the backup vacuum pump, and reduce the load according to the vacuum job. When the vacuum reaches the trip value, the turbine protection should automatically trip, otherwise manually trip the turbine and handle it as a fault shutdown. Turbine trip protection system. The turbine trip system includes manual trip and EDS trip units, which are systems that connect EDS protection over speed protection system and trip solenoid valve. All shutdown signals generated by turbine trip commands are sent through the turbine trip system, causing the shutdown and the solenoid valve to accumulate and trip the unit. Emergency governor. The emergency governor is a very important security device for steam turbines and is one of the modern overspeed protection devices used to prevent severe overspeed of the turbine. The normal operating speed of the system turbine is 3,000 rounds per minute. When the unit speed rises to 110% to 111%, 3,300 to 3,330 rounds per minute of the rated speed. The flying hammer in the emergency governor will act and hit the tripping device of the safety device, achieving emergency shutdown, prevent accidents causing damage to the steam turbine. The emergency governor should undergo regular testing to ensure that the device operates correctly and reliably in emergency situations. Manual interruption system provides the crew with a means of manually interrupting the crew. During the emergency situation, the emergency state of the unit, the operator manually pulls the shutdown mechanism to activate the blocking device, release high-pressure safety oil, quickly close all inlet valves, and block unit. EDS protection interruption system. Upon receiving the electrical shutdown signal, the EDS protection action causes the shutdown solenoid valve to lose power, connecting the high-pressure safety oil to the discharge oil, releasing the high-pressure safety oil. Quickly closing all main steam valves and regulating valves, and then interrupting the unit. Classmates, in this class we learn about the overview and main protection of steam turbine protection system. That's all for today's learning. Thank you all.